So for the 10th day, it looks like the simulation wasn't that good and we ended up in the river, but we managed to survive and swim to the shore, and we have to use again our radio device to talk to the elves. But I guess it's even more broke now because it's wet, so we have to fix the display, and somehow we managed to figure out how the display works. It seems that it has a chip that has two types of instructions, a no-op instruction and an addx instruction, which takes as input one number. It can be both negative or positive. And this CPU, it has a single register called X, and the addx instruction will basically just add that number to the X register. We also know that the no-op instruction takes only one cycle to finish, and the addx instruction takes 2 cycles. So for the first question, I guess it's just like to check that we read the input and we are able to simulate the instructions. We have to go through all instructions and compute the X value at the 20th cycle, the 60th, and then from 40 to 40 steps. And after we get all the X values from those indices, we multiply them by their respective index and then sum all these signals together and get the answer. Then the more complicated part comes in the second question, where it tells us that these signals are actually some sort of signal for the screen. So this screen is split into 40 columns and 6 rows, and in each cycle it draws 1 pixel on the screen. So from the first cycle to the 240th cycle, it draws all the pixels, and this screen uses the X register to figure out if a pixel should be lit or turned off. Okay, and also the X register indicates a single number, but the sprite position can be one above or one below that X value. I guess this somehow made the problem easier for generating inputs. So with each addx instruction, the X register will change its value, and this X value will also modify something called the sprite position, which is a 3-window item that moves along the x-axis, and it can have any value. I mean, X can have any value, so this sprite position can reach anywhere. So what we want to know is that if in each cycle the cycle index, or like the cycle number, overlaps with this sprite position. So maybe it would be simpler to think of it as whether at cycle number y, x minus y in absolute value is less or equal to 1. So yeah, basically if the cycle number is next or overlapping with the X register. I mean, this was pretty hard to understand, but if you try to follow along the example, it might get easier to understand. So maybe I'll go through the first 3 or 4 lines because you don't need more than that. So we start with the sprite position at position 1 because that's where X starts. Then we start the add X15 instruction, which takes 2 cycles, so it's not done yet. During the first cycle, we check the pixel position and the sprite position. The pixel position is 0 because it's the first cycle, and the sprite position and the cycle pixel position overlap, so we draw an lit pixel. Then in the second cycle, the add X register or the instruction didn't finish yet, so the position 1 and the sprite position still overlap because the sprite position has a width of 3, but after we draw the lit pixel, the X register will move to 16. Now the next instruction is add X minus 11, which didn't finish yet. It will take it 2 cycles. The pixel position is 2 because this is the second cycle. Now we try to see if the second pixel is overlapping with the sprite position, but it doesn't because the sprite moved the previous step. So we draw a dot, which is like an off pixel. Then the next cycle, we increase the position to 3, like the next one, and the addx instruction didn't finish yet, so we still have to draw an off pixel, but at the end of this cycle it will end and it will move the X back to 5. So for the next cycle, if we look at it, we see that the next pixel position will be again overlapping with the sprite. So we again draw on pixel. So basically this is how it works. And after you reach the 40th position, you go back from the beginning of the line, but you go down with one line. So at the end you will get a 40:6 image where you have to read all the letters from that screen. So for the solution, I created an enum called instruction, which can have two types, NOP and addX, which takes an i32 as input. Then to read the input from the file, I implemented again the from string trait. If the string starts with NOP, then it means that it's a NOP instruction. And if it starts with addX, then it means that we have to create an addX instruction. And again, the input is really simple. We just have to split on space and get the integer from the string. And finally, we just return the addX constructor with the input of value. I also created this helper function that returns the number of cycles for each type of instruction. So NOP returns 1 and addX returns 2. To parse the entire input, as in many of the previous days, I use this lines to vec function to parse each line as an instruction. Then for the first part, I created a total number of cycles variable to keep track of what cycle we are in. Then a sum variable that will hold the sum for the first part, and an X variable that will hold the X register. Then for each instruction, I simulated each individual cycle. So we go from 0 to the number of cycles, we increase the total number of cycles, and if we are on a position that's stated in the statement, like if the total number of cycles is 20, or if the total number of cycles minus 20 is divisible by 40, then it means that we can increase the sum with X times total cycles. After we go through all the cycles for that instruction, we can finally modify the X register. The NOP instruction, it doesn't do anything, but addX modifies the X register. For the second part, I created an empty CRT for the screen. It's a 40:6 vector, like a 2D array, and we'll still use the total number of cycles and the register. Then very similarly to the previous part, we loop through all the cycles, but what we have to do this time is to figure out on what row and column are we on the screen. And then, as I said in the example, if the X value is adjacent of or overlapping with the CRT column, basically with the Y value, we have to turn on that LED, I guess. And as previously, we apply the instruction after we go through all the cycles. And yeah, then I just displayed the screen. So yeah, basically this was the 10th day. I guess it was simple, but it was also very interesting. I always like these types of problems where you generate images or stuff in Advent of Code. So yeah, if you want to check out the code, you can find it on my GitHub, and bye bye. See you guys next time.